Hey guys, just wanted to take a minute to do this quick video for you guys that are still feel like you're struggling a little bit with the average atomic mass, or those of you that haven't felt like you've had enough time with it. Use the video as talked about before. Pause it, rewind it, scrub it back, just so you make sure you got an understanding of this. If you have any questions, of course, as always, ask me in class, come see me before school starts in the morning, or come to me during lunch. So, here's what we're doing with calculating the average atomic mass. We went over this a little bit in class, so I'm not going to go through every little detail with you, but what it is, we have these isotopes. So for this example, we're doing the element titanium. So I have isotope 46, 47, 48, 49, and 50. And remember what this number over here is. This number is just simply, it's the mass number, so it's the number of the protons plus the neutrons. And what we're looking at, what makes an isotope different, is more neutrons inside of it, because as you guys remember, the protons identify what element it is, and that can't change. So we're going to roll through, and your first step, your very first step, and this is the step where I told you guys I think a lot of students make mistakes, is they don't do this step first. These percent abundances here, so 8.25%, 8.44%, 73.72%, 5.41%, and 5.18%. In all of this, this is where I think we make the biggest mistake, is we forget this step. You cannot use these percentages. Divide them by 100, so we just have them as decimals. So we'll divide all of these by 100. So 0.0518, 0.0541, it's 0.7372, 0.0744, 0.0825. Now these are the decimals of these percent abundances, and we're going to have to use them to find our answer. And now this is the key. Once you've done this, you're set and ready to set your problem up and put it in the calculator. It's as simple as we're going to take these mass numbers and we're going to multiply with its corresponding percent abundance, the decimal that we came up with, and we're going to find the summation of all of these together. Okay? And for those of you out there, I know it's a little different, but we're just going to use this mass number because it's really, really close, and I just want you to get the ability of how you're calculating these out. So, mass number 46, and I'm going to use parentheses, and it's going to be times, well, let's use units. Units are important. We'll do AMUs for now. We'll do grams per mole later on when we start dealing with the mole concept. So 46 atomic mass units times this decimal, because it corresponds with titanium 46. So 0.0825, and then we're going to add next one, 47 atomic mass units times the corresponding percentage that goes with it, 0.0744 plus 48 is the next mass number, times corresponding 0.7372 plus, I'm just going to continue this down because I don't have enough board space to write out. If I was writing on my paper, I would try to keep it together. And even if you have to drop it, like one of these, I give you 5 isotopes, you have to drop it, that's fine. As long as you just show the mathematical properties happening, we're fine. So it did 48 last, let's go 49. 49 times 0.0541 plus 50 times corresponding percent abundance, 0.0518. That's it. All you have to do is punch that in your calculator and punch it all together. Guys, be careful with this. A lot of errors will come from y'all just wanting to throw this in your calculator really fast and just run through there. Don't be scared to use parentheses. I'm one of those people that absolutely love to use parentheses. So I'm going to use parentheses 46 times 0.0825 in parentheses plus parentheses 47 times 0.0744 in parentheses plus parentheses 48 times 0.7372 in parentheses plus parentheses 49 times 0.0541 in parentheses plus parentheses 50 times 0.0518 in parentheses, hit enter, and the number that I come up with when I did all this, if I can get my marker to cooperate, is 47.9183 atomic mass units. So that's what I came up with, and I can use my periodic table to see if I'm really close. If you're really close, you're probably right. So the periodic table has 47.867, and that's really, really close. So I'm saying I'm right, and I'm good to go. If you have any questions on this, please, please, please come and see me. Please come ask questions. Guys, I don't want you to mess up because you haven't asked a question or you're uncertain about something. This can come back to bite you, okay? So please, come see me with questions.